And we are live. Hey there. So thanks for tuning to Excel Island and welcome to the channel. My name is Abatan Sheriffdeen, and on this channel, what I have been doing lately is that I have been live streaming my learning journey to become a data analyst. And actually, I am a top rated plus freelance data analyst on the Upwork platform. So I've had major success from the platform. What I'm trying to do is to upskill myself and learn new things about SQL, Power BI, definitely Python. Here it now. I'm trying to add to my knowledge and prepare myself for the job market and opportunities out there. So the goal is to learn consistently for the next 100 days. 30 minutes, 45 minutes, or maximum 1 hour using the Datacamp resources. So I am currently subscribed to a 1 year subscription on the Datacamp platform. Let me show you what it looks like. And so far, so good. I've been able to learn consistently using the resources on the Datacamp platform for the past 51 days. Today is day 52. The target is 100 days. I'm super excited. So I'm currently on the career track data analyst in SQL from the resources on Datacamp. So you can see I am on the career track, data analyst in SQL. So I'm trying to sharpen my SQL skills and be able to apply for high paying jobs out there, jobs that require someone highly experienced in SQL. So not actually so experienced, but I'm taking my skills to the next level. So I'm so happy that the goal is 100 days and I've passed at least 62% out of the whole career track in the data analyst in SQL career track. I also plan to live stream the learning journey of data analyst in Power BI in preparation for the Power BI certification I'm planning to take next year. You get it now. So if I show you what the data analyst in SQL career track looks like, so this career tracks contains 11 courses. You can see it contains 11 courses. So far, so good. I have been able to complete 6 courses consistently for the past 51 days. So I should be through with the seventh course today or probably tomorrow. So I'll start the eighth course on the what on the career track. And we have 12 courses in total plus one. Okay, we have 11 courses in total, one project, then the statement of accomplishment. So that's the whole goal there. You get me? So the goal is to finish this career track in the next 100 days, and I plan to build at least up to 5 to 10 portfolios using data sets online to practice my skills and build portfolios. Also, as I said earlier, I'm a top-rated plus freelance data analyst on the Datacamp on the Upwork platform. So I've been freelancing consistently for the past 2, 3, 4, getting close to 5 years now. And I have a coach who has been putting me through freelancing for those years. So his name is Benga Adebi. Get it now. And my coach currently has a course out there which will help you to become a successful freelancer also and start your own freelancing business. And you can also become a full-time freelancer like I am. So I'll leave a link to the course under the YouTube description here. The name of the course is the Freelance Client Magnet course. And what this course does is that it teaches you how to become a successful freelancer from like Upwork, Fiverr, LinkedIn, and also remote job websites. How you can land gigs, high paying clients using those platforms that I've mentioned. It also teaches you how to optimize the social media account and position yourself for gigs or for potential clients to hire you out there. I'll leave a link to the course under this description. Make sure to check it out. Also, let me show you what Benga DB looks like on Twitter. So if you go to the tweet on Twitter or any social media page, but on Twitter, you can also get his social media pages. So if you go to Twitter or X, you can see Bungadevi. So you can check out his profile, look at his pin tweets. You see lots of testimonials from students who have been taking part of it, from students who have taken part of his course or who has purchased his course. There are lots of testimonials out there to show you that the course is highly rated, one of the best courses about freelancing and establishing a successful freelancing business. out there. So do check it out. The link to the course is in the YouTube description here, so you can check it out there. So going back to my learning phase here. So usually before I continue from where I stopped yesterday, I'll probably have one or few areas to review. Because now, so if I come here, if I don't have any areas to review, all I have to do is just continue from where I stopped yesterday. So I'll just continue the introduction to statistics part of the course here, so I can just complete the course. So this chapter, normally all the chapter part of the course on the Datacamp platform always have 4 chapters. So all the course in the career track always has 4 chapters. So I've completed chapter 1, chapter 2, and chapter 3. So I'm currently in chapter 4 of this course in the career track called Introduction to Statistics. I'll just continue from where I stopped yesterday, and let's finish this. I stopped in correlation.
We've talked about relationships between variables. Now let's look at one way to measure relationships: correlation. Recall that we can use a scatter plot to visualize relationships. Here, we plot the costs of water versus gym memberships in different cities. It's hard to determine whether a clear relationship exists between these two variables. This is where the Pearson correlation coefficient, often referred to as the correlation coefficient, comes in handy. It was developed by Carl Pearson and published back in 1896. It quantifies the strength of a relationship between two variables, producing a value between -1 and 1. This number corresponds to the strength of the relationship between the variables, and the sign, positive or negative, corresponds to the direction of the relationship. Note that the Pearson correlation coefficient can only be used for linear relationships, meaning changes between variables are proportionate. For example, let's say that a bottle of water costs $1 and the monthly price of a gym membership is $20 in London. If water costs twice as much in Paris, then a gym membership should cost $40. Here's a scatter plot of two variables, x and y, that have a correlation coefficient of 0.99. The data is closely clustered around a diagonal line, so we describe this as a near perfect or very strong relationship. If we know the value of x, we'll have a good idea of what the value of y could be. Comparing this to a correlation coefficient of 0.75, the data points still trend up and to the right, but are more spread out. This plot shows a correlation of 0.56, which would be considered a moderate relationship. A correlation coefficient around 0.2 would be considered a weak relationship. When the correlation coefficient is close to 0, x and y have no relationship, and the scatter plot looks completely random. This means that knowing the value of x doesn't tell us anything about the value of y. The sign of the correlation coefficient corresponds to the direction of the relationship. A positive correlation coefficient indicates that as x increases, y also increases. A negative correlation coefficient indicates that as x increases, y decreases. Given what we now know about correlation, what do we think the correlation coefficient is between water costs and gym costs? Well, there isn't a clear line, suggesting it isn't a very strong relationship, but the values both tend to increase together. So perhaps there is a weak to moderate positive correlation. A trend line makes it easier to visualize the relationship. The Pearson correlation coefficient is 0.35, confirming a weak to moderate positive relationship between the cost of a gym membership and the cost of a bottle of water. Be careful when interpreting the relationship between variables using the correlation coefficient. Here is a plot of life expectancy and the cost of a bottle of water. There is a correlation coefficient of 0.61, suggesting a moderate positive relationship. Does this mean increasing the cost of water will increase life expectancy? Well, it is important to distinguish that just because a relationship exists, it doesn't mean that changes in water costs will result in a change in life expectancy. A popular phrase among statisticians is that correlation does not
Correlation does not equal to causation.
equal causation. When looking at relationships among data, it's important to ask what else might be affecting the values. The cost of a bottle of water is typically higher in locations with stronger economies, and they may offer better access to high quality healthcare. So, perhaps life expectancy is not affected by the cost of a bottle of water, it is actually affected by the strength of the economy. This is known as a confounding variable, which is something that affects the data we are analyzing, but was not accounted for when assessing the relationship between variables. Now let's see how strong the relationship is between watching this video and understanding correlation.
Does not, it means correlation does not imply causation. So because X is happening doesn't mean Y will be happening. So identifying correlation between variables. So you saw that adding a trend line to a scatter plot is a great way to get a sense of the strength and direction of the relationship between variables. An app has been provided for you to display scatter plots with a trend line for data about cities. The data points represent a city and its location in the plot is determined by the cost of bottles of water and a monthly gym membership in that city. The task is to describe the Pearson correlation coefficient for the cost of a bottle of water as the dependent variable and the annual hours worked as the independent variable. So choose an independent variable and dependent variable. So say the cost of bottles of water as a dependent variable. So cost of bottles of water is a dependent variable and hours work hours work as the independent variable. So what's this? This is definitely weak. This is definitely negative because it's not moving up. Let's see. And that's correct. So what can correlation tell you? So in the last exercise, you saw a weak to moderate negative relationship between the cost of a bottle of water and the number of hours worked annually in different cities. So here is the plot as a reminder. So your task is to choose the statement that accurately describe what you can reasonably conclude from this visualization. It says an increase in the number of hours worked annually causes a decrease in the cost of bottles of water. That's wrong. An increase in the number of hours worked annually is related to an increase in the cost of bottled water. A decrease in the cost of bottled water is the cost of bottled water. A decrease in the cost of a bottle of water causes a decrease in the number of hours annually. An increase in the number of hours worked annually is related to a decrease. So it says an increase in the bottle of water, an increase in the number of uh, a decrease in the cost of bottle of water causes. Let's see that. Mm, cost a bottle of water. One, two, three. An increase in number of hours worked annually is related to an increase in the cost of bottle of water. So an increase in number of hours. So there's an increase here. It is increasing down here. An increase in number of hours worked annually causes a decrease in the cost of bottle of water. No, it's related. They are not related because it's related to a decrease in the cost of bottle of water. Hmm. Okay. So if there's an increase in the number of hours worked annually, it's related because they're not related at all at all. So increase, increase. So the hours, number of hours worked increases and the cost of bottle of water. Hmm. I see 1,000, 1.5 year, 1 4 year, and this increases, cost of bottle of water comes down. Okay. Mm. We say it's related. Let's see. Perfect. It is reasonable to conclude that relationship exists between the two variables. However, there may be other factors influencing their values that is difficult to identify why this relationship is occurring. Oh, okay, that makes sense now. It's confused, but that doesn't mean what because one is happening, it's causing the other to happen. Exactly. I understand better now. Okay. Based on the graph, as the number of hours work is increased, you can see it is increasing to the right. There's a decrease in this cost of bottle of water. You can see all of them came down here. Understand me? That doesn't mean they are related. You get it now? Okay, that makes sense now. Let's see now. So confounding variables. You have been asked to perform an experiment to investigate the relationship between neighborhood residents and lung capacity. You will measure the lung capacity of 30 people from neighborhood A, which is located near a highway, and 30 people from neighborhood B, which is not near a highway. Both groups Both groups have similar smoking habits and a similar gender breakdown. Which of the following could be a confounding variable in this experiment? Oh, confounding variable. So a confounding variable is what else is affecting the what. So it says difference between neighborhood residents and lung capacity. This is located near the highway, and people from neighborhood B, which is not near the highway. Okay, we have lung capacity, neighborhood, smoking status. Hmm. So a confounding variable is what is not measured, a variable that is not measured but may affect the relationship between our variables. What could be the confounding variable? So we need to figure it out like this. We already know that we have to perform an experiment to investigate the relationship between neighborhood residents, so neighborhood A and neighborhood B and their lung capacity. But there is a highway. One is located near the highway. So you could say the highway is not even listed there. The neighborhood A, neighborhood B. Hmm. Measure the lung capacity of 30 people from neighborhood A. This is located and 30 people. Also, this one says 30 people from location B, neighborhood B. But one is near the highway, the other is not near the highway. So we say but they both have similar smoking habits and similar gender breakdown. So we can use smoking habit and gender breakdown. So we're looking at probably the air pollution in the area exactly. So that is the confounding variable that is not measured. If the one to correct, you would expect there to be more air pollution in neighborhoods situated near the highway, which may have caused lower longer capacity. Exactly. That's the result there. So the last part is interpreting hypothesis test results.
Now let's talk about how to interpret hypothesis test results. Suppose we want to test if there is a difference in life expectancy in Chicago and Bangkok. Our null hypothesis is that no difference exists, and our alternative hypothesis could be that Chicago residents have a longer life expectancy than Bangkok residents. We can collect data on the age of death from 100 residents each in Chicago. Now let's talk about how to interpret hypothesis test results. Suppose we want to test if there is a difference in life expectancy in Chicago and Bangkok. Our null hypothesis is that no difference exists, and our alternative hypothesis could be that Chicago residents have a longer life expectancy than Bangkok residents. We can collect data on the age of death from 100 residents each in Chicago and Bangkok. This histogram shows the life expectancy sample distributions for each city. The mean life expectancy of the Chicago sample is 79.3, and for Bangkok, it's 73.9. But how do we know these are the actual mean values for each population? Life expectancy of the Chicago city than Bangkok residents. We can collect data on the age of death from 100 residents each in Chicago and Bangkok. This histogram shows the life expectancy sample distributions for each city. The mean life expectancy of the Chicago sample is 79.3, and for Bangkok, it's 73.9. But how do we know these are the actual mean values for each population? We could collect age of death data from 100 more residents in each city. This time, we get different results. So, are we sure that a difference in life expectancy data from 100 more residents in each city? This time, we get different results. So, are we sure that a difference in life expectancy really exists? Or are the results due to chance? Put another way, do the samples truly represent these populations? We can't collect entire population data, so one approach is to perform sampling with replacement on our original data from each city and calculate the mean life expectancy for each sample. Repeating this 10,000 times and visualizing the results, we can see normal distributions for mean life expectancy in Bangkok and Chicago has a larger expected value. So, can we now conclude that a difference in life expectancy truly exists? When drawing conclusions in hypothesis testing, we use a metric called a p-value. This is the probability of achieving a result at least as extreme as the one we have observed, assuming the null hypothesis is true. Suppose we want to know the probability of a sample mean for Chicago life expectancy being more than or equal to 82, given a population mean of 79.3. We can visualize the sample means distribution and look at the total area from 82 onwards to determine the p-value of 0.037, meaning there is a 3.7% chance of observing a mean life expectancy of 82 or more. We can visualize the p-value for our two sample mean distributions as the total area that overlaps between them. So, how small an overlap is needed to be confident in our conclusion? To reduce the risk of drawing a false conclusion, we set a probability threshold for falsely rejecting the null hypothesis. This probability threshold is known as alpha, or the significance level. It's decided before collecting data to minimize bias, as a researcher may choose a different threshold after they've seen the data, so that they can draw a conclusion that serves their interests. A typical value for this is 0.05, meaning there is a 5% chance of wrongly concluding that Chicago residents live longer than Bangkok residents. After data collection, we look at whether the p-value is less than or equal to alpha. If the p-value meets this criterion, we can feel confident in rejecting the null hypothesis. If this occurs, we describe the results as being statistically significant. In hypothesis testing, there are 4 potential conclusions we can make based on the null hypothesis. We can wrongly reject our null hypothesis when it is actually true. This is known as a type 1 error. We can wrongly accept our null hypothesis when it's false. This is known as a type 2 error. We can correctly accept the null hypothesis when it's true, and we can correctly reject the null hypothesis when it's false. Having set alpha, we can now draw a conclusion based on our sample mean distributions. The overlap of distributions accounts for less than our threshold for alpha, 0.05, meaning the likelihood of the difference in mean life expectancy between the two cities occurring by chance is less than 5%. Therefore, we can reject the null hypothesis and reasonably conclude that the mean life expectancy in Chicago is higher than in Bangkok. Now let's check our understanding of how to interpret the results of hypothesis tests.
Interpreting the results is kind of tricky. So significance level versus p levels. We've learned about two very important elements of hypothesis testing: significance level and p-values. It's very common to get this too confused, especially when you are new to statistics. So in this exercise, you have been provided a statement and need to match the definition provided based on whether they accurately describe alpha or p-values, which is significant level or p-values. So this is set before data collection. So this is said before data collection. Mm, that is the significant level, also known as alpha. That is the significance level. This is a threshold assigned to prevent the probability of falsely rejecting the null hypothesis. Mm, Then similar to p-value. To reject the null hypothesis, the value must be less than or equal to alpha. To reject a null hypothesis, the value must be less than or equal to alpha. That is the p-value. They describe the probability of obtaining a result at least as extreme as those observed. They describe probability of obtaining a result at least as extreme as those observed. This metric is calculated after data has been collected. Let's see. Oh, I missed it here. So this is a threshold sensor when the probability of falsely rejecting. That's the p-value now. Let me see. So if p-value is less than alpha, you get the null hypothesis. Okay, that's the significance. So this describes probability of obtaining result at least as the same as the covered. So you have to set the significance level before data collection. So significance level is also known as alpha. Okay. Uh-huh. Understood better now. Let's see. So type 1 and type 2 errors. So you are interested in whether there is a difference in average weight between adult men in Madrid, Spain, and Berlin, Germany. So your null hypothesis is that there's no difference in weight between men in Madrid, Berlin, and your alternate hypothesis is that men in Berlin are heavier than those in Madrid. So alpha has been set to 0.05, which is the significant level, right? Which is 5%. And weight of all the adult male residents from each city has been collected. So sampling with replacement has been performed to produce 10,000 samples, sample means of both cities. What conclusion can you draw based on the sample mean distribution here? Sample mean distribution. Adult male weight in Berlin and Madrid. Oh, what can we draw? Oh, it says we get no hypothesis. Men in Berlin are heavier than men in Madrid. Why do you say that? Look at the sample area. This is Berlin, this is Madrid. So the null hypothesis that there's no difference, Abby, between men in Madrid and Berlin. Okay, reject it. Accept the null hypothesis. There's no difference between men's weights in Berlin and Madrid. It's possible to it is possible it is impossible to determine this from the plot. That's it. We get the null hypothesis. Men in Madrid are heavier than men in Berlin. Hmm. Hmm. You see, there's no difference between them because of the shape of it. So I think they overlap together. But if you look at it, it says correct. There's no substantial overlap between the distributions. So you cannot reasonably conclude that a difference exists in average weights between men in each city. Weights for comparing the cost. Let's recap. And also you can see there's no overlap between them. There's no real overlap. But aside from that, the p-value is not even known. But I need to watch back. So I say let's look at the range now. Look at how large an area overlap between the two distributions. So the overlap is not even large at all. Okay. But the goal is to know how to calculate that on.
Fantastic work on completing the course. You learned about data types and the different branches of statistics, then worked with measures of center and measures of spread. You learned about the probability of independent events and conditional probability for dependent events. You discovered probability distributions and saw how to use the area of a distribution to calculate probability. You moved on to the binomial, normal, and Poisson distributions. You also discovered the importance of the central limit theorem. Finally, you learned the fundamentals of hypothesis testing. You were introduced to the null and alternative hypotheses and saw how randomization, treatment, control, and blinding can be used to strengthen experiments. You saw how correlation helps to quantify the relationships between variables. Lastly, you saw how alpha and p-values can be used to draw meaningful conclusions from hypothesis tests. So, where to now? Statistics is one component of data science. If you want to learn more, we have courses introducing data science. Or perhaps you're interested in machine learning, which combines statistics and programming to build predictive models. Congratulations again, and thank you for taking the course. I hope you enjoy applying your newfound statistics knowledge.
We're not going to data science yet. We still have data analyst to go with. Okay, we've completed this. So next course in 4 seconds. Let's go back to dashboard. I think the next course is exploratory data analysis in SQL. Okay, we'll come back to all this later. Okay, this has 4 chapters also. But let's go back to the dashboard and see what it looks like. We are starting the next course here. We've achieved our daily goal, SQL learning streak. So I go back to the career track now. And we see that we are 63% completing the career track. So I think the next one is Yeah, exploratory data analysis by Christina. So, so I have to take this course also. Then move to this and boom. So we continue from here on day 53 learning journey. All right. All right. So thanks for staying to the end of the live stream. So if you found value in this video, do make sure to give the thumbs up. Let me know your thoughts in the comment section and smash the subscribe button to support the channel and put on the notification bell so you know anytime I drop a new content or I'm about to go live. All right. Don't forget to check out the freelance client magnet course using the link in the description. Go purchase the course and I'll see you on day 53. Peace out.